The B200 is NVIDIA's newest generation of data center GPU. This chip has, a lot of enhancements over the Hopper series. It has, much more HBM to store larger models in, a lot more compute and efficiency per watt, and new capabilities in terms of FP4, allowing you to quantize your models into smaller bit rates to fit even more AI in a single accelerator. What the B200 really brings to bear is a combination of more memory bandwidth, and more flops. And what that means practically is you're going to be able to store larger models on a single GPU, access that model data faster, and do more computations with that data with the same number of seconds. What does it mean practically? It means that your models are going to run faster. It means you're going to train faster. It means you're going to produce more tokens per second per dollar of GPU that you purchase. B200s really shine with large models. Before, when you used to have a model that wouldn't fit within a single H100 or H200, you'd have to break it up and serve it across multiple GPUs. With the additional memory, the B200 can handle a lot of these models on a single chip. That reduces the complexity of your operation significantly. The B200 also has the ability to be broken up into smaller chunks. This allows you to run potentially many smaller models on a single chip, all while harnessing the faster floating point performance of the chip, again, leading to more throughput and a lower cost per token. We see this work especially well with both LLMs and diffusion models. The B200 is indeed a powerful chip, but it does require some optimization both in terms of the operation and the software itself. Operationally, the B200 is a beast. It throws off a lot of heat. Making sure that the operating conditions of the data center really enable the B200 to shine means you need to cool it effectively. A lot of times that now means liquid cooling. Not only in order to get the cooling job done effectively to allow the processor to perform in an unthrottled capacity, but also running in the liquid cooling mode saves you power, that saves you money. So when you're operating a liquid-cooled B200 computer, we're going to be able to perform at its max because the temperature is going to be controlled super well, and do all of this using less fans and less kilowatts of power. Now, on the software side, running B200s, the Blackwell is a new architecture over Hopper. So, some libraries have already been upgraded to work well with the Blackwell architecture. Others are still in the process. We're going to want to rebuild with the latest version of the CUDA compiler. We're going to want to make sure that all of the kernels are optimized for the Blackwell architecture. And for those of you at a really low level who have done kernel optimization, some of that may need to be reworked in the Blackwell architecture that might not just port over from Hopper. Like any data center scale GPU, service and support are critical to effectively running your workload. These are complex machines, so having a first-class tier 1 24/7 support organization on hand to not only fix the bits that break, but also answer your questions when you're having problems running your workload is a key component to really getting the most out of these machines. B200s are appropriate for anybody who is running inference on large-scale models today. So if you're thinking about any of the larger open source diffusion or LLMs that you can get in Hugging Face and other places, these are tailor-made for a B200. Additionally, people who are doing scaled fine-tuning, like full fine-tunes and sort of foundation model development are going to get a lot out of the B200's architecture and capabilities, allowing you to have more passes, optimize more, try more things, and ultimately achieve better results in your model training or fine-tunes. Yeah, well, I think almost anybody producing or consuming AI at scale will get a lot of benefit out of the B200. Again, people who have the large models are going to see fantastic return on these Blackwell chips. So again, if you have a large proprietary model doing video, image generation, your own internal LLM, maybe you're in biopharma pharmaceutical industry and you've created your own, ultra large model, these are the types of folks that are going to see great payback with the Blackwell. And the ability to get more AI for your dollar allows more exploration. It allows more refinement. What we're trying to do is try to figure out how much more workload we can put within a given capacity of budget and compute that we have, and Blackwell is really at that sweet spot. As a seasoned operator of data center GPUs, Corvex is in a great position to offer our B200 offering to our customers because we do have that great tier 1 physical support on site 24/7 experience with liquid cooled facilities and liquid cooled chips, and ultimately being able to run large GPU fleets at scale. We're in a great position to help people who want to either dip their toes into Blackwell or double down, upgrade, migrate to Blackwell, how to do it. We also have a great software team on staff who can help you, if you have done custom optimizations, understand what may need to be upgraded or changed, and maybe even help you along in that process so that you get the most out of the architecture as you migrate to it. If you found this content on the B200 useful and you have any other questions, you can call one of our Corvex engineers today.